morning, dear students. Today we will discuss about the concept of optimum generation allocation, including transmission losses. So here, generally, the power plants are located far away from the load centers. That's why we must consider the transmission losses. Here, first we have to assume the n number of generating plants are present. So here the operating cost of each plant is C1, C2, C3 up to Cn, and the power generated by each plant is Pg1, Pg2 up to Pgn respectively. So where Ct is total operating cost of the entire system, Pd is total power demand, PL is total transmission losses. So here, by using this all operating costs of cost of all generating plants and power generation of all generating plants, we need to we need to formulate the problem. So here, first from the all operating cost, so total cost equal to summation I equal to 1 to n Ci. So where Ci is C1 plus C2 plus C3 up to Cn. So consider this is equation number 1. Next, total input to the generating plant of all. So that equal to Pgi, that equal to summation I equal to 1 to n Pgi. So this is equation number 1. So generally total generation in any power system that equal to total power demand plus transmission losses. So by using this one, so we can write summation I equal to 1 to n Pgi equal to Pd plus PL. So now, so we assume total transmission loss is a fraction of generation. It is nothing but total transmission loss is equal to function of all generations. So next we need to formulate the problem. The problem consists of both objective function and constraint equation if it is equality constraint or inequality constraints. So compulsory the problem consists of both objective function and constraint equation. Here the objective function is minimize the overall operating cost that equal to Ct equal to summation I equal to 1 to n Ci. This is equation number 4. Subjected to the constraint equation, that is summation I equal to 1 to n PCI that equal to PD plus PL. So here we can rewrite, I can rewrite this above equation as summation I equal to 1 to n PGI minus PD minus PL equal to 0. So this is equation number 5. So this equation is called as equality constraint equation. So this total problem is called as constraint minimization problem. So here this problem can be solved by using Lagrangian multiplier technique. So for that, so we need to write the above equation as L equal to Ct plus lambda into Pd plus PL minus summation I equal to 1 to n Pgi. So this is equation number 6. So here to get the values of lambda, so here we need to differentiate the above equation with respect to Pgi and equate it to 0. Then we will get dou L by dou Pgi equal to dou Ct by dou Pgi plus lambda into 0 plus dou PL by dou Pgi minus 1 equal to 0. So from this we will get dou Ci by dou Pgi plus lambda into dou PL by dou Pgi minus lambda equal to 0. So finally lambda equal to dou Ci by dou Pgi plus lambda into dou PL by dou Pgi. This is equation number 7. where dou Ci by dou Pci is nothing but incremental fuel cost, dou Pl by dou Pgi is incremental transmission losses. In short term, I consider it as ICI, and this incremental transmission losses I consider as ITL. So from equation 7, so lambda into 1 minus dou PL by dou PGI equal to dou CI by dou PGI. So from this we will get the equation is equation for lambda dou CI by dou PGI by 1 minus dou PL by dou PGI. So where so Li is nothing but penalty factor. So that Li equal to 1 by 1 minus dou PL by dou PGI. So this is penalty factor of the power system. So at last here we are finding the penalty factor of the system. So this method is also called as penalty factor method. So next here, so this Li is nothing but the penalty factor for ith power plant. So if for first power plant L1 equal to 1 by 1 minus dou PL by dou Pg1, for second power plant, so L2 equal to 1 by 1 minus dou PL by dou Pg. Similarly, so this penalty factor is equation is same for all power plants present in that particular power system. So at optimal dispatch, all penalty factors are equals. That's why we will get if there is two power plants, L1 equal to L2, like that. Now we need to consider for optimal dispatch problem. Thank you for watching.